Okay, guys, gals, and non-binary pals, here we are at the end of Chapter 5, Chapter 5.3, on adding and subtracting polynomials. We're starting here at question 1. We're all following along, of course, and if you're at home listening to it for the first time, just use this as a study guide. It says, Jeanette and Tim find the answer to 3x squared minus 5x, a binomial, subtracting this binomial. Jeanette claims that the simplified answer has 3 terms, where Tim says, no. It's 2 terms. Who is correct and how do you know? Well, there's 2 different ways we can solve this. The first way sucks, the second way is not so bad. The first way is we can actually figure out how to model this by drawing 3x squareds and drawing negative 5x's. So this box represents the first binomial. And if I have to take away from this a positive 4, if I look here, I don't have any positive 4s, do I, to remove. So if I did want to put positive 4 in there without changing the value of 3x squared minus 5x, I could put in 4 zero pairs, and this value inside this box has not changed. It is still 3x squared minus 5x because these are all zeros. But what it does allow me to do is it does allow me to remove positive 4. So if I do so, I can circle them and remove them, just like that. And then it says I have to remove 2 negative 2x's, which is good because I don't need to add any more zero pairs. I have them here, and I can remove 2 negative x's, just like that. And if I look what's left in the box, I know that there is 3x squareds left. I know there's still these ones here left, which is a negative 3x. And now that I remove positive 4, I end up with a negative 4 left there. So the solution using modeling would be a trinomial, and therefore, Jeanette is correct. However, what's an easier way to do it? Anyone have a simpler solution? Keep, flip, change. You could keep, flip, change is what you could do. So if you keep your first polynomial, change the subtraction to addition, and use the opposite of the second polynomial, in this case it would be a negative 4x and a positive 2x. At this stage, if you did that, we've figured out that you can get the same answer by gathering like terms. We start with the highest degree polynomials or terms first. Your x squareds are first. There are no other x squareds, so they don't get gathered with anything. We have a negative 5x and a positive 2x, which makes a negative 3x. And then there's only one constant left, which is minus 4. And we could simplify that expression by using the keep, flip, change method, which always works and is much simpler than modeling. Question 2, what's the opposite of this expression here? Use diagrams. So if I was to draw this, that would be your negative x squareds. Positive 2x's would be your x's but shaded in to show positivity. And negative 3 will just use negative 3 interchips. The opposite would simply be the inverse of every one of those pictures, which would be this. And then what is it called? It's called x squared minus 2x plus 3 is the opposite of negative x squared plus 2x minus 3. Question 5 says, which addition statement does this model? So here, I guess we have to probably have an addition statement here, a little plus sign there. So our first binomial is not negative x squared. How many are there? 2. So we actually say negative 2x squareds. There's one here, and there's a negative x squared here, and a negative x squared here. Notice how it's a negative 2x squared. Plus 3x. That's our second term. And we're combining that with, or we're adding to it, 3x squareds, 1, 2, and 3, and a negative x. If we look through our options, the one that does say that is, I believe, the third one, right? C is the correct solution to which addition statement is represented by that diagram. Question 6 is add the polynomials, or what's another way I could say add the polynomials if I wanted to reword the instructions? Anybody? Instead of saying add the polynomials, what's another way to say it correctly? Gather like terms. Right, we could say gather like terms. So your 3x and your 2x combine to make 5x. Your negative 4 and your negative 3 make negative 7. Next solution, we have next question, we have a trinomial. So a negative a squared and negative 4x squared. Combine the invisible negative 1 with a negative 4 to make a negative 5. Keep the term itself, the a squared, as is. Negative 3a and positive 2 make a negative 1a. Remember, don't write one coefficients and don't write one exponents. You don't need either. Those are combined. And then a positive 2. Here, 5p and 5p is 10p. Positive 5 and negative 5 are 0 pairs. So when you add those two binomials together, you end up with a monomial. And finally, 2y squareds, there are no other y squares, so it just combines by itself. Don't gather your constant x, gather your next highest degree term, which is your y's. It's a positive 6y. And then a negative 15 and a positive 9 make a negative 6. So your solution for this binomial plus this binomial is this trinomial. Question 7, perform the indicated operation and simplify by combining like terms. Negative 3x and positive 6x is positive 3x. Positive 4 is the constant that does not combine with anything because it's the last term. 3n and negative 4n makes negative 1n. Don't write your coefficient, just write negative n. And then your positive 7 and your negative 4 make positive 3. 2b and negative 1b make just 1b, or a b squared. And a negative 3 and a positive 2 make a negative 1. And finally, a trinomial. These two will combine. A positive 5 and a negative 4 make a 1, or just an a squared. Negative 3 and a positive 2a make a negative 1a, or just negative a. And a positive 2 and a negative 3 make a negative 1 as a constant. Question 8, what's the opposite of each expression? If I wrote what this expression was, it would be 3x minus 1, and its opposite would be negative 3x plus 1. The opposite of this, since this is negative x squared, its opposite would be positive x squared. The opposite of positive 2x is negative 2x. And the opposite of positive 3 is negative 3. Question 9, what's the opposite of each expression? Boy, this is a tough one. Positive 9x, negative 5d minus 6, and 2x squared minus 3x plus 5 is the opposite expression. Question 12, which of these represents the opposite of this? Well, the first thing I would do if this was a test question was I just write it out. What does this say? This is actually the opposite would be this, and then you have to look for it. Well, it's not this one, that's for sure, because that's a negative x, not a positive x. Hey, it is this one. Look at that, b right off the bat. Negative 2x squared plus x is the opposite of 2x squared minus x. Use a diagram to model the subtraction. So I'm going to start with a box. And inside said box, I'm going to write the binomial here as a picture. So that's that whole binomial there. And now I have to take away 2 negative x squareds, which is beautiful because I don't need to add any 0 pairs, because I have 2 negative x squareds to remove 2 negative x squareds without adding 0 pairs. However, when I try and remove a negative x, it becomes difficult because I don't have any negative x's. So in order to do it, I have to add a 0 pair in here, so I don't change its value, but it gives me a negative x to remove. My solution would be negative x squared plus 5x. 1, 2, 3, 4, 5 is the solution. Yep. So if your next question says simplify by combining like terms, what we learned was we don't want to subtract polynomials. When we have these questions, the simplest way is to keep your first polynomial as is, change to addition, and use the opposite of the second polynomial. Once we do this, it just becomes gathering like terms, right? So when we do that, those two terms will combine to make negative 3x, and those two terms will combine to make negative 2. So the solution to this question is negative 3x minus 2. For this one, the second one, I'm going to keep, flip, change. I'm just going to get lazy and do it that way. Gather like terms. My b squareds are going to negative 5b squareds. They're done. And negative 5b and negative 4b make negative 9b. Does that answer your question? That's what you're doing to the, right, if you think about grade 7, if you had this question, right, and I put brackets around it, you're actually taking away -3 from this term. Yep, yep. This subtraction symbol, you mean? Yeah, you're subtracting, which is like adding the opposite. Correct. Yeah. So keep, flip, change, keep, flip, change. That's an easy one to do. Gather your like terms. Don't gather your 5s first. Gather your your W's. Combine those, you get -3W. And a +2 and a +5 make a +7. And finally, keep, flip, change. Uh, Tricky question. That's an M. That's an M squared. Gather your M squareds first. -M squared. Done. Your positive M is going to stay a positive M. Notice how the positive symbol that wasn't there now becomes the plus sign between it. And a +7 and a -7 are 0 pairs, cancel each other out. So your answer for D is -M squared plus A. This is Ben's favorite question on perimeter. What does this expression represent? It represents the perimeter of the triangle. What's the simplified expression? 2x plus 3x plus x. So actually, the first thing I would have done is this. I would have written it as side 1 plus side 2 plus side 3. Then I would have gathered like terms. 3x, 2x, and x is 6x. -2, +5, -3 is 0. So the perimeter would equal 6x if I actually gathered all of those sides together. And question C is interesting. If x has a value of 5, then what is the length of each side length? So if x is 5, I could substitute this x to be 5, and 5 minus 3 would make this side right here 2 units long. If x is 5, this would be 3 times 5 minus 2, which is 15 minus 2, which is, this would be 13 units long. And if 2 times 5 plus 5, this length would be 15 units long, would mean the perimeter would be 13 plus 2 is 15 plus 15 is 30. The perimeter, if x is 5, the perimeter would be 30, which is interesting because if I go back into my simplified expression and substituted 5 for the value of x in my simplified one, the perimeter is also 30 when I simplify it. Easy peasy, lemon squeezy. All right, our last question of the regular rounds are fill in this addition pyramid. 2x plus x, the brick above it is going to equal both of them, so that's 3x plus 2. This plus this is going to be 4x plus 1. And this plus this is going to be 4x even because the minus 2 and plus 2 cancel each other out. Here it's going to be 7x plus 3, the addition of this and this. This is going to be 8x plus 1. And finally, our top square will be 15x plus 4. Okay. Is that wrong?